It says write an equation of the line passing through that point perpendicular to the plane. Well, to make the equation of a line, I need a point and a direction vector. The point is just A. And then I just remember this idea that, okay, that's right. Any plane you give me has a normal vector. That normal vector is perpendicular to the plane. Well, that means the direction vector of this line that is perpendicular to the plane needs to have the same direction vector, or scalar multiplier. So I need that point and that direction vector. Now, next we need to pay attention to the form of the line. It did tell me to write my equations in parametric form. So I've got an x of t, a y of t, and a z of t. Questions on the board? Say it. That's it.
So it was like really simple.
So these will always kind of have like two hurdles. There's actually, do we know how to find the equation of a line? But B, there's some mental thing that we're juggling as far as, well, it didn't give me a direction vector. I'm responsible for extracting it from the equation of the plane. Be careful, make sure it's something x, something y, something z. If it was z equals something, maybe we'd have to rearrange it to find the normal vector. talking about 2. So 2 says consider the points, and it just gave me 3 order triples here. It didn't call them anything, so maybe to help myself stay organized, I'll call them A, B, and C. So consider these points in 3-dimensional space. Determine a vector that is perpendicular to the plane that contains the 3 points. So we said, okay, geometry, any 3 points you give me, I can find the equation of a plane. So you might say, oh, well, how do you know they live on the same plane? Don't worry. Any 3 points, we can make a plane. Well, if I want a vector that is perpendicular to the plane that contains the points, it's just find a word salad way of saying the normal vector. So without just saying normal vector, it's just describing it in words. So to find the normal vector, I'm going to make 2 vectors, A to B and A to C. And then my perpendicular vector, or my normal vector, is just going to be the cross product of those 2. Could you have done B to A and then B to C? Absolutely. Now you would get a vector parallel to this. It could be a scalar multiple of it. It could point in the opposite direction, but it's still a vector parallel to that one. Say this was a multiple choice question and you got this as your answer, but that doesn't show up as an answer choice. Don't freak out. Maybe make the 10 a 1, put it in that normal form, and then see if you can manipulate it to get one of the answer choices. Questions on 1 or 2?
Real quick.
Yep.
You calling the direction vector that because you're dealing with the
For 1, right?
parametric, because
So-
it's T, and T deals with the direction vector and not slope.
The equation of a line needs a direction vector.
Okay.
So if you want to think of it as the slope of the line.
Gotcha. This is right parametric, which that gotcha.
Let's start number 3 together. It says the curve in space is given by the parametric equations x, y, and z. Determine the points where the curve intersects the xy plane. So first, let me just ask you this. Is this a line? Why or why not? If I were to graph this in 3D, is this a line?
That is a line, although it's not equal to 0.
Why is
making
it
an
not?
equation.
Not all the equations are linear.
Yeah, to be a line, all the x, y, and z's have to be linear.
Oh,
Like something t plus something t plus something.
nice.
If everything is linear in x, y, and z, then you get a straight line in 3D. So this is just saying some sort of space curve. So some curve in 3-dimensional space. I want to know where this curve intersects the xy plane. So I have a plane along the x and y axes, and I want to know where this curve intersects. What's another way of saying the xy plane? I need an equation for the xy plane. Think back to like day 1. That would be z equals 0.
Is equals okay.
So if I'm talking about the xy plane, that is z equals 0. So it's whatever variable is not mentioned. If you want to talk about the yz plane, that's when x equals 0. So give me just a very quick point in the right direction of how to approach this problem now. If I want to know where this curve intersects the plane z equals 0.
Plug in 0 for t.
Or solve for your z of t.
You're like saying, you're basically saying it. Yeah. Solve for where z equals 0. Don't set it. or don't plug it in then for 0, set it equal to 0. That'll give you a t-value.
A 5.
What are you gonna do with it? Okay. Now what am I gonna do with that t-value?
T-value, plug it into X and Y.
Plug it into x and y, boom, you got a triple.
Oh, look at here.
Then, let's actually graph this one in Desmos afterwards, just to make sure we can, A, use Desmos, B, visualize it.
Let's go. Shoot, let me see if I can do it as fast as you do. Fast. 2 plus 3. Uh-oh, didn't give me a square. Why'd you give me a square? Give me a square. What did I do? No. Not that. Alright. There we go. So -2, 10. Mm-mm.
So again, I wanna know where I'm intersecting the xy plane. So that is the equation z equals 0. So if I wanna know where this curve intersects z equals 0, just set my z of t equal to 0.
25 minus 3.
Yeah, 22.
Yeah, 22.
5 times 5 minus
25, yeah, 25 minus 3. Good catch.
3. Yeesh.
20.
So now if I know where z of t equals 0, you're gonna get a t value. You can think of that as like when in time, at t equals 5. So now just plug that into your x, plug it into your y, plug it into z still.
Hmm.
You're gonna get an order triple.
Got you.
Let's go over to Desmos now. Don't forget to type these space curves in, these parametric equations, write it as an order triple with your x of t, comma, your y of t, comma, your z of t. Take 2 seconds, change the parameters at the bottom. The default is 0 to 1. Change it to like negative, 100 to 100 or negative 10 to 10, something like that. I changed the window a bit. I just changed the z-axis to go from negative 2 to 2.
How do you?
And you can see now in blue, I've graphed z equals 0, and that is the xy plane. And I want the coordinate, or the order triple, where that curve intersects. And we said it is the point 22, comma, square root of 2, comma, 0. So just like you saw me make a mistake a second ago and I called it 21, this would have been a clue to myself that, something happened, I'm gonna go back and check it. So you don't need Desmos to solve these problems, but just to have it in front of you and help visualize what's happening. Question 4, given these two vectors, calculate the angle between them. That's just to flip through my notes, find the angle between two vectors. Once we pull it up on our cheat sheet, we see the angle between two vectors is the arc cosine, or the inverse cosine, of the dot product of the two vectors divided by the magnitude of A times the magnitude of B. That's just something that came from our reference sheet. We're allowed to take it. Notice something about this formula here is it doesn't say whether you're in 2 dimensions or 3 dimensions. So you can find the angle between two vectors in either 2 or 3 dimensions. Doesn't matter. Formula is still the same. So this problem is just A, recalling on a known formula, and then B, just making sure we can do these computations here. The dot product of two vectors, and then knowing how to find magnitudes of vectors. To find the dot product, that's where you multiply the x's, multiply the y's, multiply the z's, and then add them all together.
So let's see what it is. 0 from 0. Right. So you just 4, 16, 20, 21. Arc 29.2.
I'm not saying no. Restore. Reading the problem one more time, it does say answer in radians. So I want to make sure that whatever calculator I have is in radian mode.
I'm in degree mode, so yeah, already. Arc cosine that 0.5. Yep. Okay. Yeah, I was in degrees.
If that was a multiple choice question, we would have gotten
I got an idea.
Okay. Yay.
questions on 3 or 4. Five says, this equation represents a sphere in 3-dimensional space. Determine the area of the trace formed by the intersection of this sphere with the plane x equals 2.
Mm.
I'm gonna give you guys a second to look here.
Yeah.
walk me through number 5, what are we thinking? So I have the intersection of this sphere with the plane x equals 2. So if I want to have Desmos just graph this. So this is exactly what we want. We're slicing through the sphere like this, and I want to know the area of the trace there.
Wow.
So how can I find the equation of that circle? Don't forget, x equals 2, so just plug x equals 2 in. Lucky for us, this cancels out, so I'm left with this. This is the circle that we see in the YZ plane. So in the YZ plane, you see a circle with a center -1, 0, and a radius of, careful, square root of 15, because it's r squared. So coming back over here just to convince you, if I look in the YZ plane, this is a circle with a center of -1, 0, and a radius of square root of 15. So now find the area of this circle. Area is just pi times the radius squared. Boom. Area is 15 pi. Now if you're looking at this problem going, well hang on, is it always just this times pi? No, careful.
Don't do it.
Because say this intersected with x equals 1. Now when I plug in 1 minus 2 is -1 squared is 1. I have to subtract that over and get a 14. This was just a special case where I'm intersecting the sphere directly in the middle. So don't always think it's going to be whatever the constant is. Questions there?
Wow.
Alright,
Here
go ahead and I'm going to give you guys some time to work on the multiple choice, talk amongst yourselves. These should be a little more straightforward. It's going to be, here's a problem, do it. Here's a problem, do it.
Could you go back to the other?
Yeah. Did I give you one of these?
Okay.
It's just
The topics.
yeah, so the topics, these are guaranteed to be on the test. And then all the normal stuff, like you're allowed a page of notes, you're allowed a graphic calculator.
Okay. Thank you. Guaranteed. Okay. And to do that. Yeah, that's probably got 215, but we don't have that as A, B, C, or D.
2.15, right? If you round that to one decimal.
But wouldn't that be 2.2?
And that's C.
Oh, duh. Okay. That it is.
Alright, do you guys want to talk about a page at a time or just at the end? Page at a time. Alright. Number one had a lot going on.
Yes.
So I've got 3 points that form a triangle in R3. Determine which of the following classifications best describes the triangle. First of all, the last one, a triangle is not possible. Any 3 points you give me, I shouldn't say that's not always possible. The only way it would not be possible if they live on the same level. Like you're not actually making space for a triangle. So just going through these quick definitions, equilateral means all of the lengths of the triangle are the same. So you can find the length of each side of the triangle, distance formula. And if you get all 3 of the sides are the same, you're looking at equilateral. Isosceles meant 2 of the sides had the same length. So if I had done this, maybe not all 3 the same, but 2 are the same, then isosceles. Well, because none of the sides are the same length, I'm looking at scaling, which means they all have different lengths, but it also could be a right triangle. And to check to see if it's a right triangle, I just want to find the dot product of maybe AC dot AB. And if you had gotten a dot product of 0, it meant that those two are orthogonal to one another. So a 90-degree angle would have given me a right triangle. So I just quickly ran through AB dot AC. I did not get 0. And you can do this very quickly because all you're looking for is a value of 0. If you get anything else, like here I start recognizing, I don't even care, that's not 0. Some quick things to mention here. You don't have to do BC cross BA. If you had done, CB, it's the same vector pointing in a different direction. You still would have gotten a dot product of 0. But really just kind of thinking about the thought process of how do you show lengths are the same, distance formula? How do you show right angles, dot products? I didn't get any of them, so I landed on scaling. Questions on 1?
So that's a Scalini.
Scaling.
Scaling. So what is that? What does that mean?
It means that none of the sides have the same length.
None of the sides.
Now, you can have a scaling right triangle, but I'm covering my ass when I say best describes it. Because it's the same thing, technically, an equilateral triangle is an isosceles triangle, but the best classification is that all the sides are the same.
Okay.
Second one, little more routine,
Yeah.
calculate the angle between the 2 vectors. So I just flip through my notes, find the arc cosine formula here. It should have been in the problem, and I will fix it before I post it. It will give you the units. It will say find it in radians, rounded to the nearest tenth, something like that. Questions there? All right. Look it over, try the next. let's go ahead and start to talk about them together, just to make sure we have enough time.
Yeah. Please.
3 says, write an equation of the line perpendicular to the xz plane that passes through the point 2, 8, -1. So you might have just kind of recognized, okay, the xz plane, that is the equation y equals 0. But I don't really know how that helps me yet. I want to be perpendicular to that plane, so I know that's kind of the normal vector. But I don't know how to extract a normal vector from y equals 0. Once you see this the first time, it never leaves you. Don't forget, y equals 0, we learned is the equation of a plane.
Right.
Technically, that is the plane, 0x plus 1y plus 0z equals 0. That means that the normal vector of the plane, therefore the direction of our line, is the vector 0, 1, 0. So perpendicular to the plane, it means that y is traveling, but x and z are fixed. So if I have the point 2, 8, -1, and a direction vector of 0, 1, 0, then I can get my parametric equations here. For multiple choice, this is super important because what if I had gotten, I get B exactly here, but what if choice B said something like 8 minus 7z? Well, that's still the direction vector 0, -7, 0. That is still parallel to my direction vector. It still would have been an acceptable answer. Please ask questions there.
Got a question? 'Cause I don't know what question to ask.
Yeah.
Where, how much is lost, some question, 9 plus 1y.
One more time?
Like 0x plus 1y.
Yep. So this y equals 0 is a plane. And if I want to write it in my standard form, ax plus by plus zz, then I have no x's. I do have one y
Which is 0, okay.
and no z's equals 0. So now I can just easily extract the normal vector from that. Once you see it, you kind of recognize that, perpendicular to the xz plane is the direction vector where y travels, everything else is fixed.
So your y is along the origin in a plane, or the plane of the origin going horizontally?
It's just saying that x and z, so in the xz plane, nothing's moving but y can travel.
Right.
So don't forget, vectors don't have to live. I understand what you're saying. This is traveling along the y-axis.
Right. Okay. Yeah. Yes. Okay.
Let's just go through the answer choices for 4, and then we'll think about the math of what would tell us that. How would I show that 2 planes are parallel to one another?
Scale.
Yep, the normal vectors would be scalar multiples of one another. What would show me that the 2 equations represent the same plane?
If the points are the same as the normal vector,
When you say points,
the points of the hold on, let me think. Because a plane is your points of your x naught, your y naught, and your z naught.
careful. Think about it in that standard form. Ax plus by plus cz equals something.
Okay.
They're the same plane if you get the same equation. If both of them can be reduced to the same exact equation, then it's just the same plane.
Right.
If you get ax plus by equals cz equals something else, then you get that they're parallel. So both of these, I'm checking to see that the normal vectors are the same. You get the same equation, same plane. You get different, constants at the end, then they're just parallel. To show that two planes intersect in a line, yeah, you're basically just showing that they're not parallel. And if the planes aren't parallel, then they intersect. And two planes intersect in a line. The two planes intersect in a single point, so you can just cross that one out. The equations do not represent a plane. Okay, let's make sure they do. How do I know that this represents a plane? X, Y, and Z are all linear. They don't have to all be, you don't need an X, Y, and a Z. For instance, don't forget up here, Y equals 0 was only Y, but still a plane. So D and E are. Alright, so here's my game plan. I'm going to check and see that they have the same normal vector. They have the same normal vector, I'm investigating A or B. If they don't, then they just intersect in a single line. So I'm going to make sure that I have AX plus BY plus CZ. That is not true for the second equation. Take 2 seconds. AX plus BY, I have to subtract the Z over, and move the 8 to the other side. Just to make them look the same, I'm going to just get a coefficient of 1 for the X. Divide everything by 5.
15 and 2.
Divide everything by 2. And right off the bat, no. I do not have the same normal vector. And you could be super explicit here and say the normal vector for 1 is 1, negative 6/5, negative 3/10. And the normal vector down here is 1, 3, negative 1. We're responsible for kind of understanding that another way of saying that two planes aren't parallel is that they would intersect in a single line. Please ask questions on 3 and 4.
Could we solve for like, it be perpendicular and then be
One more time?
Could you solve for it being like perpendicular?
Wouldn't matter, because even if they're perpendicular, they still intersect in a single line.
Right.
So not needed.
Oh, but like, if that's what we did, then it would prove.
It would.
Okay.
Questions on 3 and 4 before I flip the page? 5. The parametric equations of a curve in the xy plane are given by, and I've got x of t and y of t. So this is just exercising, do we remember how parametric equations work? Which of the following graphs best represents the curves defined by these equations? Let's start off with t equals 0. If I have t equals 0, then I have x of 0 is cosine of 0 to the third. What is cosine of 0?
1.
To the third is 1. And what is sine of 0?
0.
To the third is still 0. So I should have the point 1, comma 0. So D is out, E is out, so I'm left with A, B, and C. We saw B is a famous one where it's just cosine and sine. Flipping the order just changes the direction. But I do have something to the third. And this is just a little bit of mental gymnastics here. Which one are we thinking it is and why?
It's definitely not B.
Oh,
I'm thinking C, cause it looks like it's like a.
It's just like
inverted
normal
circle.
cosine sign would be more of like circular, but C is kind of more concave.
Yeah.
So what are the values, this is how I thought of it at least, what are the values of sine and cosine? Well, always, they're always between what?
1 and.
It also could be a circle.
-1 and 1, so 0, 1, it's always a fraction.
Mhm.
And if you raise a fraction to the third power, it should get
A negative?
small.
That's why it's smaller.
So all the values are gonna kind of bow in towards the origin. Because your x and y are getting smaller, so they should be closer to the origin. They should be closer to values of 0.
Okay.
I mean, I did narrow it down.
Yeah.
Let's check this one out. Let's make sure that this holds up.
That's not good. This is part of it. Just, origin,
So, fun fact, Desmos does not believe in to the third power. So we're gonna type in cosine squared times cosine, sine squared times cosine.
Okay. Got you. Well, look at here. Look at her.
Oh, it doesn't believe to the third.
Okay.
I don't know.
So that's what it is.
Number 6, determine the equation of a sphere with this center and this radius. That's not too bad. I think without even looking at the answer choices, I can get there. That's x minus 0 squared plus y minus 4 squared plus z minus 6 squared equals square root of 3, careful, squared. So I know my equation should equal 3. B and C are out. So I'm looking at A or D. I'm looking at D.
Is it E?
We're all good on 6, right?
It says E?
Second?
D.
D.
Why is it D?
I'm missing an x squared term in E.
But, okay, I was looking because the center is, the x value is 0.
True, so it should be x minus 0 squared.
So it's we know it's a circle, sometimes circle.
Okay.
But because we know all the coefficients, it's weird.
So something worth mentioning, just because it was a multiple choice question here, doesn't mean it will necessarily be multiple choice on the next practice test or on the real test. So this could have been a free response.
Oh,
So don't, practice just being able to recognize the equation, but also writing it yourself. This is just something that's gonna belong on my cheat sheet. Recognizing equations of quadratic surfaces. I don't have Desmos 3D in front of me, so I just have to be able to recognize them. I personally look for the paraboloids first. If something is not squared, that's a paraboloid. Everything's squared, so that's out.
It's more like a.
Cone
ellipse or
was one of our equations where it equaled 0, so that's out. If all of my coefficients were the same, then I would be looking at a sphere, but that doesn't happen here.
Right.
How can I recognize a hyperboloid? Yeah, there's different signs. It doesn't matter which one's negative. So I'm looking at an ellipsoid. And that should hold up with our intuition. It's kind of like a sphere, but maybe I'm just stretched along the different axes a little more. And again, I will show that in Desmos just to convince us. So I've got x squared plus 3y squared plus 5z squared equals 1. There we go. Alright, number 8, consider the 3D surface shown in the figure below.
Okay.
Don't forget, when looking at Desmos 3D, it will label the axes. Those labels show you the positive x-axis, positive y-axis, positive z-axis. So just kind of orient yourself. If by the time the exam rolls around and I haven't figured out a way to perfectly sketch something, I won't do it. If it's not a convincing image, I won't put it on there. I'm not trying to confuse it. So I have some sort of surface. It's a cylinder. So don't confuse it with a sphere. It's not going to be x squared plus y squared plus z squared. It's going to be missing something. If it was less than 1, it's shading everything inside the cylinder, which is not happening. If it equals 1, it's everything on the cylinder and all the way down the axis, so it could be. Minus, no, that's out. Shaded inside and including, but it's still not shading inside. So now I'm torn between B and E. What is the only thing I need to...
It's E, it'll be along the y-axis because it doesn't include the y.
Yes, it opens along the y-axis, so I'm thinking y can be anything. That means y is not named.
Right.
And if y is not named, y can hold any value, so it opens along the y-axis. So yes, E.
Why not that one of these sheets?
Mm.
Which of the following statements about R3 is false? Two distinct planes are either parallel or intersecting. True or false? That sounds pretty true. Two lines parallel to a plane are parallel to one another. Say again?
I didn't know.
True.
It is B. Watch. These two lines are parallel to my plane, but watch this. I never cross that plane. Still parallel to the plane, but these two lines intersect. It is B. Quickly, running through the other ones just to make sure we're all on the same page. Two distinct planes that are perpendicular to a third plane are parallel. True. A plane and a line intersect or are parallel. True. You've got a piece of paper and a pencil. They're either never going to intersect, or you tilt one of them just a bit, and eventually they will intersect. Two distinct lines perpendicular to a third plane are perpendicular to one another.
No.
Two distinct lines perpendicular to a third plane are...
They're either parallel or the
This should
same,
check, this
right?
should check parallel.
Okay.
Last one. Let B be the vector in three-dimensional space. Calculate the angle alpha between the vector and the positive x-axis. So this just comes from our notes. That is going to be the arc cosine of the x component of the vector divided by the magnitude of the vector. So again, we just got two different things on our cheat sheet. We've got one for the angle between two vectors, one for the angle between the vector and the positive axis. For the sake of time, we'll go ahead and stop there. I will post the solutions to this on Blackboard. I'm also going to post 2 other practice tests for you guys to try. Maybe do one tonight, maybe do one tomorrow night. Any questions?
Are you gonna post the solutions to those two?
Yep.